Okay. All right, so here's number one from the study guide. I'm probably just gonna do the evens. I'm sorry, the odds. Just because it's getting pretty late, and I don't think doing them all is going to help you anymore, than that. So we'll get started. We see that we've got two integers here. We've got two variables. They're all being multiplied. Nothing's being added. No addition or subtraction signs. So this is one term actually, and we're going to combine all the x's with the x's and the y's with the y's. So let's just focus on the integers first. We've got 2 times 2 is 4. Alright, so now if we have variables with the same base, what we can do is we can take their exponents and just add them. Because this is like saying x to the negative 3, that's like saying x to the third is down below, being multiplied to x to the second on top. So if I were to cancel these guys out, notice that this is bottom heavy. Okay, you're going to have 1 left over, but he'll be on the bottom. So it's like saying negative 3 plus 2 is negative 1. Okay, so negative 3 plus 2 plus 4. Okay, if I add those two, that's 6, and then 6 plus negative 3 is actually 6. I meant 3. Now y, you've got 4, 6, 8. I've got a total of 8 y's, and that's your final answer. There's nothing else to do. You're not solving anything. There's no equal sign. You're just basically condensing an exponential expression. All right, so number 3. Number 3 is the same process. Let's see, does this have a back? Yes, it does. Okay, so I'm going to have to not do that. So number 3 is x to the third, y to the second, times 2x to the second, y to the negative fourth. This is basically the same principle. You've got 2. You've got a total of 5 x's being multiplied to each other, and then these two together would give you a negative 2, because positive 2 plus negative 4 is negative 2. But you're not going to see that in your multiple choice. You're going to see 2x to the fifth, and y is actually in the wrong location. He should be down below and squared. So you put him in the denominator, because remember, a negative exponent means they need to change position. They're in the wrong location. Okay, number 5. Number 5 is a little different. Hopefully when I'm doing these, I'm copying the problem down correctly. If I don't, then they might not match the answer key. Okay, so what I'm doing is here, I can approach this a couple ways. I can actually multiply the insides, then raise it to the negative third, or I can distribute this negative 3 to all of them. Now, I'm more inclined to make more mistakes if I distributed the negative 3 to each and every one. So I'm going to shrink this guy in the parentheses first, then respond with the negative 3. Alright, so let's see what we got. We got 2 times 2 is 4. Let's see, I've got, I'll go in alphabetical order here. I've got 5 A's being multiplied to each other, and then I've got 5 B's being multiplied to each other. Okay, so now what this means then is now I will distribute that negative 3 to each one of these, and this is a little bit easier to do. So I will have 4 to the negative third, A to the negative 15, and B to the negative 15. Okay, so notice that when you are raising to a power, the whole thing here is being raised to this power. Okay, it's not like you've got A just being raised to the third. That's not what's happening here. You've got this whole expression being raised to the negative third. So that's why we multiply to each of these exponents here. So these guys all have negative exponents. They are in the wrong location. So they are all in the denominator. 4 to the third power. Now remember, once you move them, they actually become a positive exponent. 4 to the third power is 64. You have A to the 15th and B to the 15th. And that's it. There's nowhere else to go. All positive exponents, and there's nothing else that you can actually simplify. Alright, number 7. So here's a combination of both. You've got 2A to the third, B to the fourth, raised all to the fourth power, and 2A to the third, B to the fourth. Okay? Okay, now this is the kind of stuff that you see a lot in calculus. So this is actually pretty useful stuff. but it's kind of hard to understand, like, well, what am I going to use this for? Well, the trick is that you really won't use this to any significance until you're in calculus, and you'll see why. Okay, so in this case, this guy is simplified as low as he can go, so we will distribute the 4 to each and every one of these, so we will have 2 to the 4th. Now, this is the most common error, is that the 4 is not distributed to the 2, and that you just substitute to the 2 variables. So do pay attention that these guys do also get raised to that 4th power, or any power that they're supposed to be raised to. Alright, so we multiply a to the 12, b to the 16th. Okay, then you're going to get 2, a to the 3rd, b to the 4th. Now notice that I did not multiply these two 2's first. This guy's tied into the parentheses, so I have to raise him to that 4th power in order to multiply by 2 first. Okay, so this would, because if you got 4 to the 4th power, actually, it does work. It does actually work in this case. But you're going to get 2 to the 4th, which is 16. And then 16 times 2 is 32. And then you've got a total of 15 A's, and then you've got a total of 20 B's being multiplied to each other. All right. Okay, so number 9, we're going to go back to the top up here. Got y to the negative half, or negative 2 times 4x to the negative third, 2x squared, y to the negative 4th. Okay, so every single exponent that we have here that is negative is in the wrong location, but I will mention though that this negative 3 only applies to the x, not the 4, because he is not in parentheses. Over here, this 4 is in parentheses, therefore he has to also be raised to the negative 3rd, but that is not the case here, so he is just going to stay a 4. Okay, so let's move everything to where it should be. Okay, the 4's. Okay, alright, so this guy is going to move up, and this guy will move down. Okay, and then they become positive once you make the move. That x squared is not moving anywhere, and then this x to the negative 3rd is going to move down. Okay, so let's clean this up. You've got 4 over 2, which is just 2 on the top. Now you've got y's here, and they're both, it's top heavy, so this means that 2 of those will go away, but he'll lose 2. So you get y to the 2nd there. And then you're going to have a total of 5 x's being multiplied on the bottom, and that's it. Alright, number 11. Let me just move this here. We got 3a over 4a to the 3rd times 2a to the 3rd b negative 4. Okay, this one's pretty simple here. Let's see. I'm going to go ahead and just cross that out and put him up to the top, and he'll become positive. And it looks like I'm going to have 3ab to the 4th. I'm going to have 8a to the 6th down there, not a to the 9th. Okay. 3, 4, so this 3 and 8 will not reduce, but I do have 1a in the numerator and 6 down here. So what'll happen is this guy will drop a degree down here, and we'll clean this up for a 3b to the 4th, 8a to the 5th. That's it, can't go any further. 13. Alright, so now we're approaching the obnoxious zone here, where you've got quite a bit happening, and this is what kind of separates the A's from the B's here, as far as grades go. Alright, so what I would do before I raise everything here to the 3rd power is let's clean up on the inside of the parentheses, because I've got lots of x's and lots of y's. So if I distributed the 3 to everything, I'm probably 90% sure I'm going to make a mistake. So I'm going to go ahead and clean up the insides first. So I notice that I've got these 2's that will cancel out immediately. I've got 1x here and 2 down there. Now there's 3 over here, but what I'll do is I'll cancel him out and drop that to a 1. And then this y will actually come down here. So what I've got is I don't have anything up there anymore. I've got a total of 4 x's, and I have 1, 2, 3, 4, and then this guy's going to come down here. He's got 7 total. So I've got y to the 7th. Now here is where I'll raise it all to the 3rd power. Alright, now that means 1 will be raised to the 3rd power, which is just 1. But then we have 4 raised would become 12, and this guy would become 21. So our final answer is that guy right there. Alright. Okay, last one for this batch, and then I'll stop the video. Where are we at? 10 minutes? Okay, so here's another large one, x to the negative 4, and again, I'm going to attack the inside of the parentheses first to clean it up. Then I will raise it to the power, because like I said, you're more prone to make mistakes the more you distribute. The more you distribute, the more you're going to make mistakes. Okay, well, first of all, I see there's a 2 and a 2 right there, so I'll just cross them out. I can do that before I even start adding them up. Okay. Also, these 2 are in the wrong location. Okay, so what is it going to be raised to? 3rd? Okay. So, looks like that 2, those 2 will go up. That x to the 4th will come down, so this guy came down, and this guy went up. That canceled out. There's a 2 left. That 2 is still there. I've got, cancel, there's 1y. And I still have that x to the 3rd. Okay, so those guys will go on, and he will drop 1, okay, because we've got a total of 7 down here. So if I have 2, that means I'm going to have a total of 5 x's and 1 y. Alright, and that's it. That's as low as you can go. Alright, hopefully with multiple choice situations, those will be pretty, hopefully pretty obvious.